Hello. So let's talk about pediatric and adult dosage based on body weight. Whenever we talk about medication based on body weight, we generally are converting from pounds to kilograms. And we also know that for every 1 pound, there is 16 ounces. And a lot of times, especially when we talk about children or babies, they are measured in ounces. So we need to know how to do those conversions as well. So let's do example 1. It says we have an order here of 1.8 milligrams intramuscular stat for a child who weighs 79 pounds. So the drug resource indicates that the usual intramuscular or subacute dosage may be initiated at 0.05 milligrams per kilogram per dose. So we want to know, is this safe? Is this going to be a safe dose or not? Well, let's calculate it. We have a patient who's 79 pounds. I'm going to put it over 1 because my patient always goes on top. And then I'm going to use my needed conversion. I know that I need it in kilograms, so that needs to be on top. I need the pounds to reduce, so I need the pounds on bottom. If you wanted to do formula method over here, you would do 79 divided by 2.2 times that 1 kilogram. So if you want to use formula method, you can. Just remember, sometimes when you round, when you do this, you may end up rounding, and that can throw you off a little bit. So just make sure and read the instructions. And then I'm going to multiply this by that 0.05 milligrams per kilogram per dose. And I'm going to say, okay, my pound reduce, my kilogram reduce. Now I'm left with milligrams per dose. And now let's multiply it out. So we got 79 times 0.05 equals, and then that's going to be divided by that 2.2. So it gives me 1.795454 repeated milligrams per dose. And if we round to the nearest hundreds, well, this is the hundreds, and we look at behind it, say, is it equal to or greater than 5? Yes is my answer. So we're going to plus 1. And what happens? This 9 plus 1 becomes 10, adds 1 here. So we're rounding approximately of 1.8 milligrams per dose. So I'm going to say this order is safe. Because remember, if it's safe, the answer would be the order, which in this case is 1.8 milligrams per dose, will be less than or equal to the recommended max. And in this case, they only gave you one recommendation here. They just gave you a max. In this case, it is equivalently to 1.8 milligrams. So yes, this order is safe. So if the order is safe, let's look at the next part. If the order is safe, how much will you administer? So you have this, and this would be great for the formula method if you want to use it. We're going to take our order, which is 1.8 milligrams, and we look at this, and we have our dosage strength. So we know we're going to divide by the 5 milligrams, multiply it by 1 milliliter. So now we're going to say, okay, make sure and clear your calculator out, or you have a scratch piece of paper. I'd love to know that you'll be able to do this without having to use a calculator. 0.36 milliliters, and this would be how much you would administer. Okay. So let's move to the next one. The next one says we have this order here. 20 milligrams intramuscular every 4 hours for pain, or as needed for nausea, excuse me. It's a pain, I meant as needed. A child who weighs 44 pounds. Again, in the resource indication, the drug resource says 0.5 to 1 milligram per kilogram per dose. So we have a minimum and a maximum, and we want to know if the order is safe. Well, it's good to calculate both the minimum and maximum because they can order less. So if we calculate the minimum and the order is less than the minimum, it's not going to hurt them, but it probably won't affect them any either. So you definitely, this is good to know because you need to go check back with whoever prescribed the order for verification, because you don't want to give them medicine and it's not doing them any good, right? So this would be good to check. So what we need to do is we need to take our patient's weight, which is 44 pounds, divided by 2.2 pounds times 1 kilogram. So we could set it up that way if you wanted to, or I'm going to erase this. So if those of you want to leave it this way, go right ahead. If those of you who want to do a different way, let's take the 44 pound, put it over 1. Let's multiply it by the 1 kilogram divided by 2.2 pound. And we're going to multiply it by the 0.5 milligrams per kilogram per dose. And so what we need to do is go through here and mark out the kilogram, the pound. We're left milligrams per dose. That's what we wanted. So now let's take this and say, okay, we got 44 times 0.5, all divided by 2.2. And that would be 10 milligrams per dose. So that's a minimum. Now let's find the max. So the maximum, we're going to take our 44 pounds. And again, if you calculated this up over here, you would already have it. And you can just plug it in. Just be careful about the rounding part. And then times that 1 milligram over a kilogram per dose. So we have what, the 44 times 1, all divided by 2.2. And that gives me 20 milligrams per dose. So this is our max. To answer that question, is the order safe? We're going to say the order is equal to 20 milligrams and it's less than or equal to the recommend max, which is 20 milligrams. So yes, the order is safe. Well, since it's safe, let's calculate how much we would administer. Okay, so if the order is safe, we know we got a supply of 50 milligrams per milliliter. That's my dosage strength. For those of you who forget, that is a dosage strength. Remember, you take both parts, here and here. All right, we're going to set it up. Our order said 20 milligrams. We got 50 milligrams times that 1 milliliter. So I'm going to say 20 divided by 50. And it's going to be 0.4 milliliters is how much we will administer because the order was set. All right. So now I'm going to go to number 6. Some of these you're going to do, we're going to do in class. So what we didn't do today during this, I want you to look at it, try to do it outside of class. Number 3, 4, and 5, try to do it outside of class. And then when we meet back again, we're going to do 3, 4, and 5. Okay, I'm going to do number 6. Number 6 says we have an order of 2.1 grams. IV every 8 hours for a child who has serious joint infection. The child is 95 pounds. The drug reference indicates IV or intramuscular, and it says that children 50 to 100, so there's a minimum and a max, milligrams per kilograms per day divided every 8 hours. And this maximum safe allowance would be 6 grams per 24 hours. So there's a lot of information here. One, let's start with the day divided every 8 hours. So in 24 hours, we're going to give a dose every 8 hours. All right. So 8 goes in 24, 3, and then 3 times 1. So it means it's 3 doses in 1 day, right? That's what it's telling me. Okay, so now what we want to do is we want to know if it's safe. So first, let's find the minimum, the maximum and stuff. Okay, so we have a patient who weighs 95 pounds. And again, if you wanted to, let's just do that. Let's since we're going to use this patient's weight 4 times here, if not more. Let's take that 95 pounds. Let's put it in formula method. And let's calculate 95 divided by 2.2. So here we go. This is where I was talking about the rounding part. This is what we get. And if we round here, we're going to get this. So it's important that we be careful, because here I didn't ask you specifically what is the kilograms for this patient. So if I did ask that and you said 43.2, it's going to give us a different number than the 43.181818. So since it's not specifically asked to give that number right now, we're going to factor it in every time, because it can knock you off by hundreds of points. And then sometimes it's not that big of a number to knock the number off. So let's do this. So we have a patient that weighs 95 pounds. So we have a patient who's 95 pounds. I'm going to multiply that by 1 kilogram over the 2.2 pound. And we're going to do the minimum, which is 50 milligrams per kilogram per day. And this one did ask per day, so we're going to leave this one alone. So I like to go through here and just mark out, just make sure that, you know, the pound reduced, kilograms reduced, I'm left with milligrams per day. I set up the way I need it. So what I need to do next is take that 95 times that 50 and then divide it by 2.2. And this gives me 2159. I'm going to round to the nearest tenths, 0.1 milligrams per day. I may ask you to round to the nearest hundreds. I believe I did in our software. So let's just do that. Let's just stick with, because we're talking about milligrams, I said round to the nearest hundreds. So it's 0.9 or it's 0.09. Okay. So that is my minimum per day. What I'm going to do is I'm going to take that answer. And I am going to factor in this right over here. It's 3 doses per day, because we're wanting now to know how many milligrams per dose. So I got 3 doses. Oh, but if you look, I want to show you this. What happens to my day? My days multiply, I get day squared. They didn't reduce, so I know I set it up wrong. Sometimes it takes that to catch yourself. So I'm going to say in one day, there's 3 doses, which makes sense. We need to divide this by 3. So it's another way you can catch your error. Mark through the day. So now I'm going to take that 2159.09 divided by 3. And it says, and let's round to the nearest hundreds. Oh, what happens is I get this, but when I round to the nearest hundreds, I get, because that 9 looks at the number behind it, add 1, because that goes to 10. So this is my minimum per dose. Okay, I'm going to shrink the page a little bit. I hope you can still see it. I just want to be able to have everything on there. Now let's go to the next one. It says minimum milligrams per day, or excuse me, maximum. So now we're looking at the maximum amount. So I got 95 pounds over 1 times 1 kilogram over 2.2 pounds times that 100 milligrams over a kilogram per day. So we'll go through here and let's just mark out the units that reduce. Milligrams per day, that's what we wanted. So now I got 95 times 100. And then we're going to divide it by 2.2. And let's just close out. Okay, 95 times 100 divided by 2.2. All right, so now we got 4,318,18, and I rounded to nearest hundreds. Here's my maximum per day for this patient. I'm going to take that number. And I'm going to divide by 3 doses. So I get 1,43939 milligrams per dose. I'm going to change this. I'm going to highlight this in another color for a particular reason. I'll go over it here in a minute. All right. So if we want to know the order is safe, is it safe? Well, this is in 2.1 grams. We're in milligrams. I know that for every 1 gram, it's 1,000 milligrams. So I'm going to come over here and do it right here. So 2.1 grams over 1 times that 1,000 milligrams over 1 gram. So 2.1, and there's a shortcut. You could just move the decimal, the number of zeros. So I have 2,100 milligrams is what was ordered for this patient. So we got to compare it. Is the order, so we've got to say the order here is 2,100 milligrams. Is it less than or equal to the recommended max, which is 1439 milligrams per dose? So this, no, this is not safe. Well, let's stop for a second and say, let's factor in the maximum daily allowance right here. Safe allowance, max safe allowance. Before I completely say, no, this order is not safe. I mean, it's not clearly because of that. It's definitely too large. They're giving more than what's recommended for that patient. Let's look at the absolutely recommended. It says that 6 grams in 1 day. Times that 1 day, 3 doses, which gives me 2 grams, which is also 2,000 milligrams per dose. Still, again, the order is greater than the maximum allowance. So this order is not safe. Okay. All right. We will move on from here on our next class setting.